Coordinates in 3 dimensions. So here we have 2-dimensional Cartesian coordinates, x, y, and a basic representation of Pythagoras' theorem is this. Now in 3 dimensions we have x, y and z, and now a basic representation of Pythagoras' theorem is x squared plus y squared plus z squared, and then you square root. Example 1. We want to work out the distance OP from the origin to point P. On this diagram it's difficult to imagine where exactly point P is. We can improve by doing this. So all I've done is I've drawn a cuboid and placed point P on one of the vertices. And now we can tell that when x is 2, so along the x-axis here, this will be 2. Y is 1, so along the y-axis, right there, y is 1. And along the z-axis, there, z is 5. We're looking for the length of this green line, OP. Now along the base here of this cuboid we have a right angled triangle. It's a right angle in this triangle, and this side is of length 2 units and this side is of length 1 unit. So the length of this line will be 2 squared plus 1 squared, and then we square root using Pythagoras' theorem. And now in this right angled triangle the length of this side is given by the root of 2 squared plus 1 squared. This side is of length 5 units, so using Pythagoras' theorem we can work out OP, the hypotenuse of the triangle. So we've got this side squared, so that's the side we've got there, so we square this side, we square this side, then we square root the whole thing, and you can see that the root and that square will cancel, so you've got 2 squared plus 1 squared plus 5 squared, square root, and that will be OP. And this is just the x coordinate for this point squared plus y squared plus z squared. So drawing all of these right angled triangles wasn't really necessary. We can just use this simplified formula. This is Pythagoras' theorem in 3 dimensions, and if we put the values straight in for x, y and z, simplify, OP is root 30. To work out the distance between these 2 points, so we want this formula, and all it's saying is it's the difference in the x coordinates. So you can either do 1 minus 8, or you can do 8 minus 1 here inside the brackets. It doesn't make any difference about the order. And then we do the same with the y coordinates. We're looking for the distance between them, so either 3 minus 6, or we can do 6 minus 3. And then the same with the z coordinates. Subtract them, put them in brackets, squared, simplify. So the distance AB is root 131. Example 3. Now we have an unknown value here, but the distance between A and B is given, it's 3. So we set up Pythagoras' theorem again in 3 dimensions. So the distance 3 goes here, we know that already. And we've got the 5 and the 4, if you subtract them, square that distance. The 0 and the 2, you subtract those again, you square. The 3 and the k there, you subtract them, you square. And then we can simplify by getting rid of the third first, so square both sides. Then we've got a quadratic equation. We simplify it and solve. We have 2 possible values for k. For practice, try these questions.